Right now, college students across the country are getting ready for a competition, but it's one you might not know much about. It's called Solar Splash.
Since 2016, the UPRM Solar Boat team has competed in the Solar Splash event held in Springfield, Ohio. We went from scoring 9th place overall to 1st place in 2021 and last year, where we finished with a total score of 953.74 points. We participated in the event using 3 different hulls, one of which included electronically controlled hydrofoils. In order for our team to win this year, new key performance goals had to be achieved. Our main aim was a complete redesign of the drivetrain in order to improve our system's hydrodynamics and efficiency for both endurance and sprint events, as well as a new, upgraded solar array configuration with a power increase up to 720 watts. The Solar Boat team started in 2014 and is formed by students from the electrical, computer, and mechanical engineering departments. Made this year's team. First up, the Mechanical Engineering Department. All members of the Drivetrain and General Mechanical Design Division. Then, we have the Electrical Engineering Department, the Solar Systems Division, and the Power Electronics Systems Division. We have the Computer Engineering Department. All members of the Data Acquisitions Division, and our team advisor, Dr. Guillermo Serrano, a professor from the UPRM Department of Electrical Engineering. We're a team based on the island of Puerto Rico, in the Caribbean, where sunny beaches and tropical rainforests surround our scenery. Our university is located on the western part of the island and is one of the largest campuses of the University of Puerto Rico. Our university is most known for our engineering and agricultural sciences. Since we aren't located in the US mainland, we had the additional challenge of having to ship our boat to Ohio. The team built a 16-foot wooden crate to transport the boat and most of our tools about 4 to 5 weeks prior to the Solar Splash event. We understand the importance of designing everything with a purpose, paying special attention to the technicalities of integrating different components to achieve a desired performance goal. The biggest task is to get the whole system to work perfectly. Not just the hull or the propellers or power or motor, but every component working together seamlessly. After deep analysis of the 2023 Solar Splash performance, we determined that our biggest opportunity for improvement was the design of a new drivetrain system. We sought to decrease overall system weight and losses due to drag and poor flow dynamics. The team developed the drivetrain designs using Fusion 360, ANSYS FEA, and CFD softwares as primary tools. Overall, the total system weight and drag reduction achieved was a staggering 46.81% and 3.53% respectively. 3D printed prototypes were created as concepts and for dimensional validation. The manufacturing of the drivetrain itself was outsourced. All metal components were fabricated out of aluminum 6061 using a 3-axis CNC machine. Plastic components were 3D printed out of ABS resin. A high-performance Agni 95R electric motor powers the boat with a 1-to-1 geared Yamato 302 gear case. The system's maximum performance is at 22 kilowatts or 29.5 horsepower, dispatching 0 to full speed in 1.1 seconds. In 2021, the hull was the lightest and the fastest the team has ever developed. With a weight of only 50 pounds, it's capable of 19% less drag at 3 meters per second than our previous hull. A fine keel with frontal elevation provides better water displacement, resulting in endurance speeds of 3.64 meters per second. The planning section incorporates hard chins on the side of the hull to decrease drag, while a 15-degree lower keel extends from the middle to the back, providing stability at high speeds. A solar boat needs its solar panels. This year, the competition allows for up to a 720-watt configuration for factory-made arrays. After analyzing last year's performance, plus new possible panels, we finally decided on an array of 4 Alerska solar panels of 180 watts each, resulting in a configuration with the allowable maximum wattage. Our Genesis charge controllers use maximum power point tracking to maximize the power output to the PV array at any solar condition. Due to the new array changes, we had to design and manufacture a whole new frame support structure. The frame was composed of 6 lightweight expanded polystyrene foam boards, machined using a 4-axis CNC machine. They were divided into 2 separate structures. This new EPS core was then laminated with a composite layer of carbon fiber and epoxy resin, providing the necessary strength and stiffness to resist any incoming stresses. An extensive battery analysis is done every year, looking to maximize both energy and power output. Since 2016, the Odyssey Extreme PC950s and PC1100s have been the best match for our system, so every improvement over the years has been achieved while using the same batteries with 2.2 kilowatt hours of energy. Custom copper bars have been designed and fabricated to minimize electrical losses for the 36 volt and 24 volt arrangements. The previously used 2-motor controller configuration was changed to a single Kelly controller KDH72121E for both high and low speed configurations, operating just above 600 continuous amps for 36 volts and operating less than 100 continuous amps for 24 volts. The controller has an unsurpassed 99% efficiency according to our testing. Additionally, a new Race Capture Pro telemetry system with live data transmission has been implemented for an improved data acquisition and visualization process. Our boat performs differently according to what configuration we set it to. For endurance, a specific propeller is mounted onto the gear case, designed to produce 228 newtons of thrust. The battery bank is set to 24 volts, along with the AK18036 MFE Alerska 720 watt solar array. For sprint speeds, a different propeller is needed to produce 600 newtons of thrust. The battery bank is also reconfigured to 36 volts. This configuration unleashes the maximum speed performance. There are several other improvements being made to the overall system, such as the addition of instrumentation, or adjustments to the center of mass for both low and high speed configurations, and so on. All in all, the UPRM Solar Boat team is very proud of what we've designed and created for this year's competition, and we're looking forward to meeting the rest of the teams there.